Hi everyone, so welcome back to our YouTube channel and let's start with our 12th video of our LeetCode 75 days playlist. And today's question is container with most water. It's very important question from interview perspective and has been asked in multiple product based companies such as Amazon, Microsoft, Meta and many others. So let's just start with the problem statement first. We are given an integer array height of length n such that there are n vertical lines drawn like a histogram basically, and we have to find the two lines that together within the x-axis form a container, and that container should contain most water, and we have to return that maximum amount of water. Okay, so as we can see in this example, we are given this input and this is basically in the form of histogram. So let's just start building our intuition from it. Okay, so we are given this height array basically, which is in the form of histogram, and yeah. So if you can see, if we try to create a container with this one and this one, so maximum it can take this part only, because if we take this, it will overflow, right? So the minimum of them can only store the water. So the width will be, this is 8th index and this is first, so it will be 7 into 1, so it will be 7 only, right? And if we okay, this is 9, 8, 1, 2, 3, 4, 5, 6, 7, 8, sorry. So 7, 8 multiply by 1, so it will be 8. Okay, similarly, if we try to take this one and this one, so minimum is this, so the maximum we can store is this one, so it will be, this is 7 and this is 8 height, and the difference between these 2 points is 7. Okay, now the maximum water will be 49. So this approach will use to like check how much maximum water we can store and take our maximum, so that we can get our answer. So let's just check how we can go and get our answer. Okay, let's just try to build another histogram. Okay, so let's just say this is one of height 3, this is of height 5, this is of height 2, this is of height 4, and this is of height 3 again. Okay, so now if we check, this is our zero index, first, second, third, fourth. So if we take this one, this is height 3 and this is height 3. So this much water they can store. Okay, now the maximum water will be 3, max the height of minimum of them, so it is 3 only, and the difference between the width between them, okay, this is 4, so 3 multiplied by 4 is 12, right? And now, okay, now we go and check with this one, 5 and 3 will be, so okay, minimum is 3 because this much we can store only. Okay, now if we take this 5 1 and this 3 1, how much water they can store? This. Okay, now it will be 3 minimum of them multiply by the width between them, it is 3, so it is 9, right? So this is how we can calculate. Okay, now the question arises how we will like check which height we need to take and how we should proceed. We get to know the mechanism how we can calculate our maximum water. It will be minimum of both the heights multiplied with the height width. So now let's come to the logic how we will calculate our different waters maximum water options. Okay, let's just have one. Okay, so this is 3, 5, 3, 4, 5 again. Let's just see. this is 2. Okay, if we see now, this is like 0, and so maximum width here is 5. Okay, this maximum width is 5, right? So now the maximum water now it can contain is 2 into 5, that is 10. If we try to take this one, so now the width is reducing, right? If you see now, the width has now become 4. If we try to take this one, now the width has become 4. Now what should one do? We need to try to maximize our height so that we can get maximum water, because we are compromising on this width, so we need to have something to increase our height. Okay, so what now we can do? 5 we have height and 4 is our width, so it will be 20. Okay, and now again, if we want to decrease our width from any side, let's just say we will do for this. Since the width is reduced to now 2, okay, so it is 5. Sorry, this one is wrong. uh, I think logic is clear, so it will be 5 into, sorry, 2 into this width, 1 2 3 4. 2 into 4 is 8. Okay, now what we can do, this is 5, this is 5. If we try to move from here, we can get our maximum height will be 5. Okay, and width is 3, so we get our answer as 15. This is maximum water you can take, and if we move here, the width will reduce to 2. Okay, now what the value we can get? 4 into 2, 8. So the logic is, if we are compromising on width, we need to maximize our height. So how we should proceed? uh, whichever height whichever height we have, okay, the minimum height, we should proceed from that index. Okay, if the minimum is here, we need to maximize this value, because earlier the next other one is already maximum. We need to maximize this value, so whichever is minimum, we should move afterwards from that. If the left one is minimum, we should move plus point to next, and if it is from right, then we need to decrease. Okay, so let's just have another. So the try run, basically the pseudocode for this, let's just write a pseudocode. Okay, what we can have? We can have one left pointer, we can have one right pointer, and the maximum water. Okay, left will be 0, right will be size n minus 1. Let's just have a small example here. So okay, this is 3, this is 4, this is 5, this is 3, this is 2. So, and this is again 2. So first left will be here now, and right will be here. Okay, and maximum water is currently 0, and we will go while left is less than right. Okay, now what we have to do, we have to find our width first. Width is left, right minus left. Okay, here is 1 2 3 4 5, that is 5, because right is 6. Okay, right is 5, sorry, right is 5 and left is 0 now. Okay, so it is 5 only. So we have find our width. Now what we have to do, we have to find our height. Height will be minimum of them, because only this much amount of water it can store, not the from above one, it will overflow. So minimum of the array, that whatever we heights array. Okay, height of left and height of right. Okay, let's just write it clearly. heights, right? Okay. Now most maximum water it can store is max water equals to maximum of the earlier max water and the product of width versus height. Okay, now we get our max water. Now what we have to do, we have to choose from which point we have to move, either from left or right. Oh, so it will be if height from left is less than height from right, that means that we already have one maximum. Okay, in this case we have this maximum, so we need to move from here. Okay, so if left is less than right, that means right is already maximum. We need to maximize our left, so we will do left plus plus, and if it is not true, then else we need to do right minus minus. Okay, now we get our answer. We just need to return max water. Okay, so this is a pseudocode behind this, and the time complexity, that is the main thing. The time complexity in this case will be big of n, since we are just iterating over the array once, and the space complexity is big of 1, since we are just using these variables. Okay, max water, left, right, okay, pointers, basically small variables, not any other thing. Okay, so let's just move to the coding part to better understand the approach and start with the coding part. Okay, so yeah, so screen is pretty much clear. Let's just store our size of the height array to a variable n. Okay, so left is at the 0th index and right is at last index, and max water is currently 0, or we can assign it int minimum. Anything will work here because the water will come uh, positive only. Okay, so we will go while left is less than right. Okay, now we have to find our width, that is what it is right minus minus left. Okay, and int height. Okay, we just need to name it height of container. It is minimum of height of left and height of right. Okay, so we have find our width and height. So max water will be max of max water and the product of width with height of container. Okay, now we have to choose from where we have to move, either increase or decrease. So if height of left is less than height of right, that means we already have one maximum, we need to maximize the other, so it is left plus plus, else we need to move from right. When we come out of the loop, we have our maximum water, we just need to return that max water. Okay, I think this is pretty much clear. Now we just need to try run our code on our example test cases. Okay, it is working fine for all of them. Let's just try to submit it. Yeah, it is working fine for all the test cases. Thanks everyone for watching. In case you do like this video, please do subscribe our channel and share it with everyone to have more solutions. I will be completing this playlist of LeetCode 75 in the following days. Yeah.